I'm going to talk about PHP and the R programming language. How many people here are familiar with R at all as a programming language? A few of you. What sort of things do you use it for? Statistical work or the charting or? No? Yeah. Okay. Well, we'll start by explaining what R is, because there's only a few of you who have obviously used it before, and I'm sure they'll correct me if I go wrong on anything, because I'm a hobbyist user. I use it because I like playing around with languages. But what is R? It's a programming language that was created way back, many years ago, 1993. Some of you probably weren't even born then. Well, I'll be polite. Most of you were probably born. But certainly weren't working as developers. It was created by two gentlemen, Ross Yahaka and Robert Gentleman, both names beginning with R, so they called it R, although it was derived from a language called S. Those of you who've used C will probably know that C came from B, which came from BCPL. Single letter names have a bit of a tradition in computer languages. It was quite a hodgepodge when it was first created, but in more recent years it's been rewritten quite significantly and is now a much more structured language. What's special about it is it's a purpose-built language. PHP is a general purpose language, pretty much. Okay, it was developed originally for web development, but it was still a general purpose programming language. R was designed very specifically for data analysis and more specifically for visualization of data and reporting of data. That makes it extremely powerful and useful for business intelligence. If you want to go download it and play around, you can find it at this particular URL. The slides will be available afterwards, so you don't need to make a note of it at this point. It's used in some very specific industries more than others. A lot of people at universities like it. Academia loves it. Healthcare, it's surprisingly popular. Is anyone working in the healthcare industry? Yeah. We've got one person there. Did you put your hand up to say you used R as well? Oh yes, R and healthcare very much go together. But it's used in a whole range of different industries, particularly for data analysis, visualization, reporting, statistical analysis, etc. From a language perspective, it provides everything you would expect from a programming language. You've got conditionals for if tests, you can do looping and the equivalents of while or repeat in other programming language. You can define your own functions which can be saved for subsequent recall in other programs that you write, basic input-output capabilities, and you've also got some database access tools for working with big data databases, in particular Spark and Hadoop. What makes it a bit different to some other languages is that certain types of data structures, arrays, vectors, matrices, are first-class data types. They're not plug-in extras. All your operations, your basic operations, like your mathematical formulae, addition, subtraction, will work on arrays, vectors, and matrices, as well as scale and numerics. All your basic functions will work on arrays as well as with scalars. So you don't have to do anything clever to work with composite data types like those. It's built into the language as standard. From a statistician's perspective, it implements a vast variety of statistical and graphical techniques for working with things like your basic statistics, classical statistical tests, F-tests, student tests, Poisson distributions and anything like that for those of you that are interested in basic statistics. But you've also got time series analysis functions built into the language as standard, classifications, clustering. And it provides built-in graphical toolkit for displaying output from any of these in chart format, make it a very good reporting tool. In competition, many of you will have probably used something like Excel. Mathematicians amongst you might have used MATLAB. There are other tools that it's a direct competitor for, like Power BI, Tableau, SAS. R is comparable to the best features of any of those tools. I come to it more from an MS Excel background than anything. I found that it was a very good alternative for some of the more complex formulae that I was developing in Excel. I could do as a one-liner in R. Additionally, it's designed to be extensible. There is a package library available, the CRAN project, and I did take a screenshot, but that doesn't really do it justice, and I hope my animation here works. You have additional categories with hundreds and hundreds of libraries available in pretty much any of these categories. So if you're working with medical data, there are libraries available for you under the medical category. You have libraries available that will handle partial data sets and can extrapolate the missing data. Multivariate statistics, you've got additional plugins that you can use. When I first started playing around with R, I'm a Windows user. Windows, if you're working with X window or with Mac, it doesn't just give you a language, it gives you an interactive environment to work with, which on Windows certainly looks something like that. You've got a command prompt window and it will populate other panes as necessary. So let's look and see why you might use R. I'm going to work through a very simplistic little project. I'm going to start with a block of data. I'll speed that animation up. PowerPoint can be a bit slow for these animations sometimes. A set of raw data to work with. Now that represents data on a growth data for business sales on a monthly basis. Starting from, well, let's convert it to a time series data structure. Starting from March 2005, because it's monthly, our frequency is 12. So what have we got now? Let's just do a print. And we can see immediately print recognizes that we're representing a time series data block and formats it accordingly based on those criteria that we've put in the time series. So starting from March 2005 right up till the end of last month, we have all our sales growth. Now, I want to do a few more sophisticated things with that. Let's look and see what it looks like graphically. Simple one-liner actually gives us a chart representation of that data as well. Not a particularly pretty chart. We can prettify our charts quite a bit. There's no grid lines, for example. Let's just add some grid lines for the sheer hell of it. There we are. That looks better. Now, that is growth since the start of the company, but in that first year, growth was rather dependent on word of mouth before we started a marketing campaign. So let's work with just a time window on that data. I can set myself a time window. Let's see, let's look at the data again. There's our print, okay. So we've got the last 10 years worth of data now that we're looking at. All just one-liners to actually provide these changes to our data structures. Let's graph it out again. Yeah, that looks quite interesting to work with. That'll give us something for our basic project. Statistics. Now a lot of languages have statistical functions built in. We've got the mean. Okay, standard deviation, if you want that in PHP, you probably want PHP Statistics plugin or extension to do that, or you've got to do a lot of math yourself. Here it's a one-liner. And we can also ask for a summary of the data, and it gives us the quartiles, the minimum, the maximum. There's a nicely formatted little table there. So a one-liner in those cases can give us some quite interesting information. We don't have to do complex calculations. We don't need any additional libraries to work with that. Let's see, we've got a density function built in. Okay, so we can plot our data running it through the density function. The density function understands that it's a time series analysis as well and plots it accordingly. ACF, autocorrelation function. Who knows what that is? Do we have any statisticians? People that work with numbers here that can that can tell us that. No, autocorrelation function. I'm not a statistician myself. I have had to do this in the past without fully understanding it. Basically, we are looking at data over the time period, and we're creating over a lagged period of several months a growth ratio for that period. I had to do it in MS Excel. Ugh, it's bloody horrible. I hate Excel. ACF is built in as a standard function for working with pretty much any data structures in a language like R, and just works. You don't have to do anything complex with it. And it even gives you some variant formats. You can work with covariances, you can work with partial data sets. You just pass an additional argument, and I would have hated to have had to do covariance and partials again in MS Excel. But by default, that just gives us a nice little chart which displays the ACF with the appropriate lag that we've called for. In this case, the entirety of the data set, because I left that as a null value. Okay, now we can start getting really smart. If you don't know what ACF was, you probably don't know what ARIMA is. Okay, explanation of ARIMA. Autoregressive, integrated, moving average. This is the type of thing that marketing departments love. They don't understand, they want statisticians to deal with it, but they love the output. What we are going to do is create us a regressed, evolving lag. It means something to some people. Okay, what we're going to be looking at when we use an ARIMA model is we're going to get ourselves what is basically the average lagged growth over a period of time, and we're going to look at every data point that falls outside of a subset of that. So all the extremes. And if we have missing data, it'll fill in the missing parts of it. Now, we don't actually have any missing data, but what we're doing is looking at the last known value, the current value, and integrating between them. We're looking at the difference between them so we can see what the growth might be. And it's a native model in R. Part of the language as standard. So what we can do is we can print it out, and we get some nice little information about it. Like I say, that means something to somebody. Statisticians, probably. Marketing people wouldn't understand it. They want to see the output with what we're doing. They don't care how we get the figure. How do we know that the data's right? We can actually produce a diagnostics test on our data. So we're looking at the standardized residuals here, i.e. the differentials between the different values, so that we can actually plot those out. The ACF graph we've got there, and we also have the box of errors. The bottom is basically everything that falls outside of our standard deviation from the baseline. So we can work with that. We can look at individual parts of it. So we're looking specifically at the residuals property of our ARIMA model now, asking for it to show us the lung box data. And there we're getting x squared 21. Okay, let's do something a bit more fancy. Let's work on the residuals squared. So just by putting the exponent 2 on it, we're squaring every individual value and redisplaying the information. That looks quite nice to be working with. I mean, this is based on actual data. We've got no missing values. We would use the diagnostics more to analyse if there were missing values in there, if we didn't have our sales growth data for March this year yet, because it's having to be recalculated by the sales department because they made mistakes. Then we could still extrapolate a likely value from it. So let's look at the density of those while we're at it. Yeah, it's a relatively nice curve to work with. So yeah, let's look at the data itself, extrapolated rather than summaries and density curves of it. So now we'll plot some lines on that chart, work out the A-B line information to use to feed in, and modify the chart dynamically to add those two lines. Now you can easily see everything that falls out of our standard, and we're going to make some use of that information. We're going to use it to predict sales growth for the next 12 months. Again, we have a nice little built-in function that does exactly that. Works with our ARIMA model, looks ahead for, in this case, we're saying look ahead for 12 months. And what kind of data does that give us? Well, we can just print out the result of that prediction in tabular form. Yeah, looks quite good. I'm not looking at the actual figures when I say that. I'm just looking at the fact that we've got a set of figures. It might be easier if we display that in graph format. So let's give ourselves a nice little graph representing that data. Ooh, this is fun, isn't it? It's really difficult displaying text like this when you've got the background on there. But this is what we want to send off to the marketing people to show our growth over the last 10 years, plus our predictive growth within margins over the next 12 months. This is to decide whether they need to do a new marketing campaign or not. We get a nice little graph there. Ooh, doesn't look so good. Growth is not expected to grow. They're going to have to do that marketing campaign. So we have just used all this data from the last 10 years to justify their spending a fortune on a new advertising campaign. But it'll keep them happy, and they're the client, the customer after all. Okay. So, some limitations of R. It's single-threaded. Well, PHP is single-threaded. We all work with that quite happily, so it shouldn't be too much of a limitation. Single-threaded basically means that your program, when you start to run it, has to run start to finish. You can't interrupt it. You can't use all these nice little Reacty type things like promises with it or anything like that. The other big problem with it is an in-memory data model. If you're working with large data sets, you need a lot of memory. Well, we're PHP developers. We're used to that. So it should be perfect for us PHP developers to work with R as well. So R can do a lot of things that PHP can't do, or at least it can do them a lot more simplistically without needing extra plugin libraries. If anyone's tried to use the PHP Statistics Library in the last few years, well, it's not being maintained anymore. I'm not even sure it runs with PHP 7. I think it does. I've not tried it myself. Last time I tried it was PHP 5.6. I think it still works, but there's no bug fixes going in there, no new functionality being added. No one is willing to take over ownership of that library. And PHP Statistics doesn't feature anything like the ARIMA model. It doesn't allow us to do predictions easily. We have to do everything the hard way. And to be honest, I'm not sure I'd like to write anything that would do it myself. I would far rather integrate with a language that does that for me. But I'm still a PHP developer at heart. So, a few years ago, the only way to integrate between the two to call our functionality from within PHP was using the exec function. Okay, we've got some problems. It's still single-threaded. So if we call an exec from within PHP, PHP can't continue doing anything. Actually, we can get away with a little bit these days with React PHP, with promises, with etc. We can play around a little bit, but we're using a single-threaded language to call a single-threaded language. PHP is probably going to have to wait until the R code has finished executing before it can continue executing. I'll live with that problem for the moment. The first thing I do is I take all those commands that I just showed you in R, and I'll strip out all the extraneous stuff so that I'm just setting the data, setting the time series and the window. Okay, I could set the window directly as the time series, but here. And generating my outputs, generating that final chart, generating that table. The only slightly different thing I'm doing here is using the PNG function and then the dev-off, which means that it will write the chart to a file that I can access subsequently, because I can't display the chart in plain text. And if I'm using exec, I'm going to be getting plain text. And I've put some placeholders in here for sprintf. And I create myself a little script builder that takes that template R script, injects the values that I want from the data set, assume I'm passing the data set as an array, it comma separates it out. Yeah, I know there's no validation checks to be sure it's all numeric data. It wouldn't fit on the screen if I did all that. Hopefully it is actually readable for you though. And then create a script runner. So I'm writing the script once the script builder has built it with the values I want to a file, and I'm calling exec to execute that file. And what I end up with my code that calls all that, build the script, pass the script to the script runner, execute it, and I'll just dump out the response that I get. This was the way any PHP developer calling R had to do it until a few years ago. Oh God. Well, it's as though I'm calling an interactive R shell. Well, I am calling an interactive R shell, which has all our standard information at the top, and then I'll just jump to the bottom of it, or near, actually that's more in the middle, the start of the display of the table. It's dumped me an array of every line of output from the R shell. The null device 1 is output to confirm that the image has been written to a file successfully. So if I was calling R from within my PHP script like this, I then have to take all that output, strip out all the CRUD, all the empty lines, everything I don't need, just to get that table, and I've got a file that's being written to a PNG file with the image. Well, at least that works quite cleanly. There is a better way of doing it. There is now an actual library that's available on GitHub that provides a slightly cleaner way of doing all this. So my script builder, keep it the same, modify the script runner so that I'm injecting the RPHP, PHPR library's RCore object, which is the actual runner, and then that is my code to actually execute it. Var dump the response. It's an improvement. It gives me a string of output. It still has every single line of code that I have executed there, together with the outputs. But at least it's giving me the data slightly more readably. Still got the null device to confirm that it's written to file there for the image. But this little R library does have one or two benefits. You can actually call it interactively line by line. So I can use a loop. So I break my script, which was a giant string, into an array of lines, and then I loop over that, process or execute the write to the process, each line one at a time, look to the response. I can filter out the empty lines quite easily, build an array of responses. Oops. There's one thing the documentation does not tell you for this library. I had a number of lines in my R script like that. That is one single command for the TS plot, time series plot. It's across 3 lines in my script. R doesn't have a problem with it. It recognizes that the first line is only a partial line. It gives me the continuation symbol, continuation prompt, lets me carry on typing until I've got a complete line of code. But the RPHP expects every single line to be a complete line. And no, I'm not going to show you what that looks like. I tried putting it on the slide for a next slide, and it stretched. So you have to be a little bit careful writing your script. On the other hand, that was my output from it. 2 responses. First one, I'm not filtering out the null device for confirming that it's written to file for the image, but I could filter that out quite easily. And then the actual data that I'm interested in. Yes, because I'm calling an R program, and R does this nice formatty thing for text output, I've got a string that's formatted. I might then have to parse it in various ways to extract the names of the year, the months, names, the values, and restructure that to something I can use from within my PHP. but at least it's a data or at least it's structured string that's relatively straightforward to parse. And yeah, you notice it also does this little wrap, only going up to July, then wrapping, and then August, September, October, November. That's because by default, R works with an 80-character screen. It's rather dated in that regard. So when I've been working with it, I've played around with a little function like this, and I can just call widescreen as the first line of my code to set the screen to whatever width I want to, which would mean that my table data there, I could get it all on one line for the month name so it wouldn't wrap in this way, making it much more easy to parse. Okay, so until a few years ago, I was playing around with the slides yesterday. I put a couple more in. There's a few functions or methods available for the R process that I was using there, the interactive process, which allow me to manage the data in various ways. I can identify, well, I can get the input that if I wanted, but I should know what my input was anyway. I can get whether there were any errors that are raised. Have I put in invalid code? And I can get it to throw an R errors exception, which I can catch to handle at any point. So it's a fairly sophisticated little library that allows me to work interactively with R. There's the problem with it. Hasn't been touched in 2 years. No new merge requests going in against it. No addressing the few remaining issues. That could actually mean one of two things. Either it's perfect, no one needs to change anything with it anymore. Anyone want to do a statistical analysis of the probability that that's the case? No, okay. I think that the author has decided he's not interested in working with it anymore. On the other hand, it is a pretty stable product already and probably doesn't need much more work. But also, there's a few new alternatives now. You don't have to work purely from the command line. First of these is called R Apache. People, I'm sure here, remember back in the day when you had to use mod PHP to run PHP from Apache. R Apache is the equivalent of that. Its strengths: it's built and installed as a shared library with your Apache. It includes access to things like the URL, your post vars, the equivalent of $get and $post in PHP. And it also includes some additional functionality so that you're not just displaying output as text, but you can return it as XML or as JSON. So you've got a structure you can work with. So you can, how do we call it? We use curl or guzzle. You're just calling an endpoint on an Apache server. You've got an R script which will then run, send you the data back. Rather than writing the script directly within PHP, what's better is if you write the script in R and get it to accept post vars for your data set. It'll even work with $files equivalent. So you can upload a file of CSV data or something like that and get R to work with that and return the response. That's a much simpler way of working because we're getting something back already structured. And then the guys that gave us R gave us shiny, in quotes. It is trademarked, I believe. No, RStudio is the company behind Shiny. What's different with Shiny? It's not using Apache as the web server. Shiny is the web server with R as part and parcel of it. It's a dedicated web server written specifically for R. And boy, for those of you that like front-end development, it has a host of widgets for manipulating everything you're working with, and you can access it using curl or guzzle again. So you just write little R scripts that'll take snippets of data. You can provide them as post data, as file data. The thing is, with R Shiny, you can maintain them in a session state. So you can upload your data once and then run a whole series of scripts that return different information about that data. You can return your graph, you can return your table of data structured as JSON. You can manipulate it in all manner of ways. If you're working with the widgets for the front-end people, that's an example of a Shiny site. I suspect that one is probably using some of the medical plugins for R that are available. But the charts for things like this are all fully interactive. Transportation, I think, if I remember rightly, that's in the Bay Area in San Francisco. They actually use Shiny and R programming to do the equivalent of 9292 NL, complete with all the OpenStreetMap maps that it produces. And fully integrated graphs and everything like that. So you can change your data values using the sliders, and the R widget, or the Shiny widget, will directly update and feed back the new variant of that graph in real time. It's not quite JavaScript doing it, because it's all going back to the server and then back to you, but it feels as if it is. There is one more option, or there will be one more option. This is the one that I'm really looking forward to. Mozilla Research Grant to rewrite or convert R plus all the CRAN package library to WebAssembly. They're hoping to do that over this summer. Then you'll be able to use a tool like PHP extension for WebAssembly to call it directly. And I'm really looking forward to playing with that. If it happens, and I hope it does, because that will be damn cool, and it'll be a lot faster than making curl requests, a lot faster than using exec. And I just like playing with these things. Okay. I have had my signal that the end is nigh for us. The doors will be unlocked in about 5 minutes. So if I haven't bored you too much, are there any questions? Ooh. Potentially calling R through the new FFI interface, yes. If someone provides all the necessary hooks for it to do so. Most of R is written in C, so it should be fairly straightforward, but be warned, there are chunks of Fortran in there. I'm not sure FFI will work quite as well with Fortran compiled code. Somehow, I think you'd have to call the C to call the Fortran, but I'm not sure that option will be available. So you may not be able to get some of the more sophisticated extensions which have been developed by aging coders who still see Fortran as the newest thing since, well, whatever the preceding newest language was at the time when Fortran became popular. Any other questions? Nope. Ooh, that probably finishing pretty much on time. Now, I was going to finish with a little bit of queuing theory, but this is actually more queuing practical. There is ice cream available in the break. You might want to go and get in the single queue that's available for ice cream before it grows too large. Thank you very much for listening to me. Thank you.